Hi viewers, welcome to today's episode of Ulari Online Maths class. In today's video, I'll be talking about the quotient rule, which is a rule of solving differentiation, right? So we've spoke about product rule, we've spoke about how to differentiate. So for today's sake, we'll be talking about quotient rule. When we say quotient, what does it mean? Quotient means when you have two functions being in the form u over v, right? This is when they are rationals, right? So where u is a function of x, v is also a function of x, right? So we have when you have two functions in the past videos, we were talking about how to differentiate x sine x, which is product rule, right? So what happens when it's y equals x over sine x? You can see it's a different form, right? Because we have x in the numerator, we have sine x in the denominator. Unlike the last one we were talking about, x on the left and sine on the right. So this very one, I'll just write the formula of the quotient rule in case you want to learn how to derive that formula. I will drop the link of the video I made on how to derive the quotient rule formula. I'll drop it in the description. So the formula for the quotient rule, we have dy dx is equals is just v du dx, right? Minus u dv dx, everything over v squared. You can see it's very direct, right? Because from here I said it's in the form u over v. We have u, we have v, right? You can see it's very direct. So our u, let's just solve this question directly, right? So our u equals x. So our du is going to be what? Du dx is going to be 1. So we have u, we have du dx. What is left is to find our v and dv, isn't it? So our v, we said, is always the function in the denominator, right? So our v is equals sine x. So what is dv dx? dv dx is equals, if you differentiate sine x, you are going to have cos x. So we have everything ready, right? So the next stage is to just substitute in the formula. Our dy dx is equals v du. V is sine x, right? We have sine x multiplied by, we have du, which is 1, minus, because we have a negative sign, u dv. Our u is x, our dv is cos x, right? But everything should be divided by v square, and our v square is what? Sine x. So sine x all squared is something as sine x all squared. But you can write it this way so that it should look more, it should be like sine square x. At least it's more okay like this, right? Sorry, this should be a 2 sine square x, such that you can see we can write this to be sine x, right? Minus x cos x over sine square x. You can just stop here, because if you like, you split because you just have one term in the denominator. If you like, you split it and put sine x over sine x, sine square x, minus x cos x over sine square x. But I don't see I don't think it's paramount for now, since we are just trying to learn how to differentiate a quotient function, right? So let's form one more example. Let's assume I'll still use this form. I've already made a video on how to differentiate tan x, right? I also drop the link in the description, so you learn how to differentiate tan x, because tan is something as sine over cos, right? Y equals sine x over cos x is the derivative. If you just differentiate this, you are going to have tan x. So no need to still waste time and be talking about differentiating this kind of function, because I've already made the video on that, right? So let's just form another function that's more complex, or should I say easier than this, just to improve our understanding on how to differentiate such functions. Let's say we want to differentiate y equals, let's say, cot x. Cot x is just the inverse of tangent, right? Because cot x is something as 1 over tangent, right? So instead of saying 1 over tan, I will just say cot, isn't it? So for cot x is something as 1 over what? Tan x. Remember, you have to find the derivative, find the y dx of this function, right? So cot x is same thing as 1 over what? Tan x. So, but tan x is what is sine over cos. So 1 over sine over cos is going to be, look at what I mean, 1 over sine x over cos x is same thing as what? Cos x over what? Sine x, because you have to reciprocate. If you multiply 1 times the reciprocal of sine x over cos x, you are going to have cos x over sine x, right? So you can see that we've successfully made the function look in the form u over v. So what is our u? We have u to be equals cos x, right? So our du dx is equals, if you differentiate cos x, you are going to have minus sine x, right? So what is left is what is our v? V is going to be sine x, right? dv dx, our dv over dx is going to be, if you differentiate sine x, you are going to have cos x, right? So we have everything set, I think, for the formula, because v du, u dv, and v squared, right? So if we substitute this, we are going to have dy dx is equals v du sine x, right? Sine x du is minus sine x, minus sine x. We have minus u, which is cos x. Then we have dv, which is cos x as well, right? This is times cos x. This is over, right? We have v square. What is our v square? Which is sine. So I'll put, like I said recently, we'll just write it in this form: sine square x, right? So let's rearrange things. I'm going to have dy dx is equals sine x times minus sine x is same as minus sine square x, right? Then minus cos x times cos x is going to be cos square x. This is over sine square x, right? This is sine square x, right? So, but there's something I'll be doing here that's more, maybe you'll be confused about, but calm down, you can understand it if you want to, because I can factor out something here, right? I have a negative, I have a negative. I can factor out a minus, isn't it? If I factor out minus, I'm going to have minus, open bracket, this is going to be sine square x plus cos square x, right? So this is everything over sine square x, right? Because minus times sine square x is minus sine square x. You can see we've gotten this function back. Minus times positive cos square x is going to be minus cos square x. Everything over sine square x, right? But we have an identity of trigonometry that says sine square x plus cos square x is what? 1. So I'm going to have, this is something as, you can just see dy dx is equal minus 1, because the whole of here is just 1, minus 1 over what? Sine square x. You can stop here, but there's an identity also for um, 1 over sine. 1 over sine we said is cosec, isn't it? So what, 1 over sine square is going to be minus cosec square. This is minus cosec square x. I know you'll be confused about maybe all the trigonometric identities I'm introducing, but I think I'll make the whole thing easier by making videos on so many trigonometric identities. At least by so doing, you understand how I did all of this. So that's it. Thank you.